KCF Technologies presents Industrial Transformation, Stories of Failure and Success from the Frontlines of American Manufacturing.
Welcome back to the Industrial Transformation Podcast. This is Jeremy Frank, and we are continuing with our conversations on the workforce, the future workforce, and how we get the people we need who can solve the problems that need to be solved. And I'm thrilled to be joined by Dr. Jess Menold, who is a person I've known for a while. She's an assistant professor in mechanical engineering and engineering design at Penn State University. So I'll just say welcome, Jess.
Thanks so much. I'm so excited to be here.
Yeah, I'm glad to have you here. I think that the things that you're working on and that you're really in a position to influence are some of the most important, which is just increasing the attraction and the enthusiasm and the excitement among young people who can become young engineers who can help go solve the world's problems. At least that's how I see part of what you're doing. Can you give us just a bit of background on how you came into the role that you're in and just your personal background?
Yeah, absolutely. I'd be happy to. So I actually went to undergrad at Penn State. So I'm a Penn Stater. Very disappointing football season, but we won't talk about that. So I studied mechanical engineering and, all growing up, I was really passionate about art. But I also loved, taking things apart and understanding how things worked. And I grew up with a father and a mother who really encouraged that curiosity. I remember my dad sitting down and taking apart the washing machine with me so we could figure out what was off balance and laying out all the parts. And so, I grew up with that support and with that encouragement to pursue engineering. And I think, I recognize that not everyone has that same push and that same support network to pursue engineering or even to consider engineering. And so, when I got my PhD and when I decided to kind of become a professor and go forward with that path, it was mainly because I absolutely love research. I love getting to kind of run my own lab and almost have a startup with a lot more stability, I like to say. But I also really love teaching. I love kind of encouraging the next generation of engineers to think creatively and problem solve effectively, and really tap into their own creative abilities. I think that that's something that is so critical to being, quote, a good engineer. Is this creative problem solving ability and recognizing that, you don't necessarily have to be the best at math and science to be a good engineer, right? You have to be really curious and you have to, have this drive to understand how things work and understand what the root problem is and try and figure out how to solve it. I think that's, to me, much more important. And so, I mean, that's kind of why I decided to be a professor, is to really engage with students and kind of provide them with that same support structure that I had growing up.
Yeah, that's great. The need for creative thinking and divergent thinking, I think, is increasingly recognized as vital. And I think I agree. I think that's just so important. I wanted just for the listeners, I think it would be good to just give some scoping of what makes what you're doing at Penn State so unique and special. Just because then it leads to kind of you're doing research and you're doing teaching, but the sumo bots, I think, is the something that I think is just really important. I want to start with of talking about, which is this. It's a senior, or I guess a junior level design class at Penn State, where you had students designing actual robots that fought each other in sumo style. Can you just talk a little bit about that and why you did it and what the outcome was and what was special about it?
Sure, absolutely. So I'm going to kind of give a more broad or kind of higher level comment first, which is that I firmly believe that, and I'm really passionate about giving students the opportunities to get hands-on, right? So I also serve as the associate director of inclusion and diversity at the Learning Factory, which is our university makerspace. And so, all of my efforts to engage students and really encourage them into design, I do it through hands-on engineering projects, right? And so, in mechanical engineering in particular, we have this very large ME 340 course, which is the Intro to Engineering, Mechanical Engineering Design course that we have for our junior students. And typically, it's taught every semester in different ways by lots of really phenomenal faculty. And when it was my turn to teach it in this past semester, I wanted to choose a project that would really push students to not only do something that was hands-on, but really engage with mechatronics, engage in coding, engage in new areas that maybe they haven't gotten the opportunity to experience. For example, like autonomous robots. And I wanted to do that because, I think, Jeremy, you're obviously very familiar with this, but in industry, right, we're all moving towards and implementing Industry 4.0 technologies, right? Like industrial Internet of Things are really becoming the future of manufacturing settings, of engineering work. And I wanted to make sure that I was giving the students, in a way, a really fun, silly competition, which robot can last in the ring the longest, but a competition that at its core had a lot of elements that were really going to resonate with them in future careers. So yeah, we chose this really fun challenge. I put a lot on the line for the students. I basically said, the winner take all, winner gets an A for sure, automatic A. I'm not sure if that's allowed at Penn State, but that's what we did. And
who cares, right?
Yeah, I'm like, now that this is being recorded, I should have looked into that. But yeah, and it was so wonderful. I think kind of creating that really fun competition spirit where these teams were just so excited and so interested in, exploring different types of strategies, whether they were going to have a defensive strategy. And I even got to teach a little bit on game theory through this class. And so it was just really this wonderful opportunity where students were getting to connect some of the control theory they had learned with some of the theory about machine design they had learned, and getting to do it all in a really tactile way it was just such a blast and such a great opportunity to teach. And I'm, of course, really thankful to the department for kind of allowing me the creative freedom to take the course in a very new direction. But yeah, it was just a blast. And I think
just to describe kind of the scenario, so picture an amphitheater, sort of a large, university classroom setting, and then down in the front in the wedge part of the presentation area, there's a circle on the floor about the size of a sumo wrestling circle, and there's two robots, and there's these students of five mechanical engineering students who have built this thing, and they've slaved for the last 3 months to embed all this technology and weaponry into it, and then they just turn them loose, fully autonomous, which is fascinating. I just think because I've been there's a show that was on Comedy Central back in the 90s, I think it probably was, called BattleBots.
Mm-hmm. Yeah.
And I think it was really kind of interesting that even ended up on a channel, a comedy channel, because it wasn't really a comedy show. But somehow somebody had an interest in exposing people to the entertainment and also the interest in actually designing machines and making them work, but also making it fun. And I just think you did a masterful job of that. I mean, there were department heads there. There were other faculty there. I was there with my kids just watching, and just the excitement of watching these college students know that their project was going to literally live or die in front of them in the ring was just amazing. I thought it was great.
Yeah, it was a phenomenal class. And again, the college and the department are so supportive of these efforts. And it was just, yeah, I totally agree with you, right? The entertainment value of that, it's almost like gladiators, but autonomous robot style. It was just so much fun, and the students were just so engaged and so dedicated, right? Because their project was on the line. It was just really a ton of fun to teach it.
Yeah, well, and what I want to talk about next is just how important that is. It's one thing. It's just it's fun. For my kids who I had there, it's fun to watch one robot try to beat another robot. But the reality is this wasn't like the BattleBots TV show where it was entertainment value. I mean, they were building like really advanced technology into these things, autonomous control using sensors to make sure that they could sense the other robot and pursue it. And just, it was really amazing technology in addition to in addition to, I guess, making it enjoyable or fun or competitive. But I think that's so important because I was actually just exposed to a number recently that there were, young people were assessed about the level of interest that they have in manufacturing and designing things. And manufacturing specifically was the lowest ranked in all categories in this assessment.
Oh, wow.
And more than 50%, more than half of the respondents among young people expressed zero interest in going into smart manufacturing. And I personally think that part of that, the reason for that, is that they just don't understand what it's like. And in some cases, it's on us for not presenting them examples like you have of what it's like to actually design amazing technology and have it do something important. I'm just curious.
Yeah.
I mean, I just see
Yeah.
you as being a real standout for addressing that, because it's a really big challenge that all of the industrial world and especially the manufacturing world is facing, but nobody has a very good nobody's addressing it very well, and I think you are. Can you comment on that?
Yeah. Well, first of all, I really appreciate it. And, I have so many other faculty to thank for the support, and it's definitely a village for all of the classes and efforts we run. But I will say, yeah, I agree with you. I think it is on us to really get students engaged and help them to understand. And Jeremy, what I will say is a little bit, it's how we're presenting manufacturing to them, right? But I think sometimes a lot, and this is what I at least find in my own experiences, is that students really, the barrier to entry they feel, right, into some of these really complex technologies is just seemingly so high to them, right? They perceive this huge barrier because it's such complex technology. And I think the success of these courses is that I don't really give them the option to say, well, it's too hard and I can't do it. And I think that by setting the expectation, in this course, I actually just this semester taught a freshman course where, they had a project where they needed to come up with an IoT technology, an IoT product at the end. And when I first introduced that to these, freshmen, right, who do not have the same level of experience that my juniors had, I was met with pretty shocked faces. But what I found you need to do is just kind of really break it down for the students in a way that they can see a path to this final, technology, to this final skill set that they're going to gain through this. Really breaking it down by using commonplace technologies now that we have, Arduinos and Raspberry Pis and all these microcontrollers that are so really reduce the barrier to coding, to mechatronics, to wiring your first circuit. And I think that showing them that yes, the final thing, an IoT product is quite complex and that's going to be hard to get to, but that the steps are not that big of a leap and that together we can kind of get there, right? Giving them that scaffolding to kind of make the leaps is really important. And it's just great to see these students at the end of a semester really look back and say, wow, for example, I just had, my final presentations with my freshmen today, and one of them made basically a desktop Roomba for their dorm room, for their dorm room desk. And it works, it can sense edges, it can sense the wall, it can vacuum. And they made this. And, when they first proposed this, they were like, there's no way we're going to be able to do it. It just seems way too complex, and they did it. And I think that showing them, yes, it is complex, but you can take an Arduino and you can wire it up with X, Y, or Z pretty quickly, and you can test things in really small prototypes that can kind of help you to get to where you're going, right? I think it's this idea of intelligent failure and fast failure, right? Setting them up so that yes, they might fail, but the failure is going to be small. And they're going to learn from it, and they're going to continue to advance through that failure and kind of build up their resilience and also their interest in the topic.
Yeah. And for anyone who might not know, which, I normally wouldn't have, what an Arduino and a Raspberry Pi, these are, microchips that what the students are doing, they're programming chips and building an actual system that's fully autonomous in a lot of ways, similar to an autonomous car. And so I think what you're really talking about, it is a big challenge. That's one of the things, I mean, those students just in that class did a lot of things I've never done. And one of my first observations was, wow, some of them are probably going to totally fail because it is a really difficult challenge. And I think maybe that's why, in the work world and in the education world, I think sometimes we are reticent to lay down a big challenge because that some people will fail and then, I don't know, be disheartened by it, or you'll have to deal with the consequences. But I think that's notable. You just took that right on. I'm curious, do you have some students that fail, and what do you do? I mean, if you give them a big challenge and they just totally lay an egg, what do
Yeah.
you do then?
Yeah, absolutely. I think failure is really common, actually. I think it would be weirder if I had, if nobody failed. That would be strange. So of course, yeah, I think I will, and I'm sure all of my students would also agree that I have really high expectations for students in my class. But I don't just have these high expectations and then kind of say, okay, go do it, right? Um, I, I think that understanding that failure is a part of learning is really core to my teaching philosophy. And I try to reframe failure as much as I possibly can. And I try to highlight times that I've failed. So, if they're trying to code something or wire something up, I'll sit down and try to help them as much as I can. And there are times when, even I wire a circuit incorrectly. And it's a great opportunity to say, okay, I just messed up and let's talk about it. Um, but I think that, again, it's really about, you can always learn something from an experience. And I think you can learn the most from failure. And so explaining to them that your robot, the final day, right, when we come in and we're going to put them in the ring, your robot might not work, right? You might put it in the ring and you might have, a case of a wire got loose, some code was broken, who knows? And it just might not work. And if that happens, it's going to be okay because you're going to be a good engineer and you're going to go back and tell me what happened and what went wrong and explain it to me. And it's not going to affect your grade, right? You're not going to fail because there was this catastrophic failure or something like that, but you're at least going to do some root cause analysis and tell me what happened and reflect on it, right? And tell me what you learned. Maybe don't bring your delicate robot over in a really bumpy car or something, right? Whatever it might be that caused, X, Y, or Z wire to fall out of place. I think, I don't know how successful I am at this. I think you'd have to ask my students, but I do really try to reframe failure as a learning opportunity, and not necessarily as, some sort of reflection on the student's self-worth.
Yeah, I think it's great. I'm reading, rereading a book by Charles Koch where he is actually, his father talks to, he's the CEO of Koch Industries, which owns some companies that we work with pretty closely.
Mhm.
And his father's phrasing on this was that failure is sometimes a blessing in disguise, but it's always the best teacher. And that definitely is my experience. As a matter of fact, I came in and did a guest lecture at, I think it was that same class at the
Yeah, it
340, the
was.
junior design. And I had done a few of those before, and I had come in and talked about something that I thought was interesting to the group, like entrepreneurship, or this is how I started a company or whatever. And it was always just sort of a dud. And then it was a professor who'd been on the business side of Penn State. I was asking him, like, what is it that you think would be most interesting to the students? And he said, what if you just come in and talk about some of your failures? and I really just kind of went with it. And I went down and just started writing down like very real episodes of failure that I've been through. and I didn't stop writing for like an hour. I had pages full, and so
Yeah.
and the students loved it because I was just talking about things I actually had experienced that were both like legitimate failures they could relate to, but also were things I'd really learned from. And I just ever since that's the only thing I talk about if I ever talk to. I'm sure you've seen that because I've just found since that's the best way to
Absolutely.
relate to people because that's what they're really wondering about.
Absolutely. And I think Jeremy, you actually, this I completely agree. Right, is that it means so much to students to hear that these successful, entrepreneurs who are these huge deals, rock star engineers, have also, messed up. So, um, with a colleague of mine at the College of Engineering, Matt Barone, we actually started doing what we call Fudge Up Fridays, right? And this is something I had been doing in my classes. I actually picked it up from a startup I was kind of um, advising in Germany. But basically, it's just this practice of having stand-ups on Fridays and going around and saying what your biggest mess up that week was, and really just making a culture of kind of laughing and learning about it, right? And kind of normalizing failure. And so, we started doing these Fudge Up Fridays with the college and bringing in really, great alumni back to come and speak about, hey, I really messed up. Here's what happened. Having professors that these students see, as these experts in these areas, having these professors come in even and say, hey, here's my fudge up, here's what I did when I was your age, right? And I failed my fluids exam or whatever it might be. But 100%, Jeremy, it's really just this normalization of failure and reframing it exactly as you said, as this learning opportunity and this opportunity to really build your own resilience.
Yeah. Yeah, totally. Can you talk about that? One of the things I wanted to make sure we talked about is so Fudge Up Fridays and Build Nights, I think is the name.
Mhm.
That, for these other things. So leaving sumo bots behind because it's constantly evolving. Can you just share some things about what you're doing going forward to really keep working at this thing to engage students and get them really focused on the things that will motivate them?
Yeah, sure. So, as a part of my efforts at the Learning Factory, which again, it's our university makerspace, so just kind of think hands-on tools, bunch of students building stuff all the time. We run these a few different events. So we run build nights, which are these really just wonderful. They're like some of my favorite times in the semester. But we have these kind of open nights in the Learning Factory where we will have either somebody from industry or somebody from a faculty member kind of come in, talk about their story, their journey through engineering. And we do this normally while we're feeding the students because I always promise to feed them if they show up for a build night. So that's important. But yeah, I mean, they get to eat dinner. They hear about this faculty member or this industry alumni kind of journey through engineering, and it's normally very personal, right? It's not about research. It's not about their work. It's about their personal journey, which I think is really important for students to hear, right? And as any good community, there's always shared experiences, and I think that that's what's key. And then following that, I run something called the Maker Ambassadors, which is a group of young women engineering students that kind of help me to facilitate these build nights because typically we have anywhere from 50 to 100 engineering students working in the Learning Factory with us, and we run really hands-on fun projects. So we've done everything from woodworking projects to we've coded some laser light pianos. We have made just a ton of stuff with the laser cutter. And the goal of these build nights is to really expose the students to, various manufacturing technologies, to give them a really hands-on design experience where they can walk out of the Learning Factory with something that they've built with their own two hands, and that also they can have that artifact, that item, that experience. And let's say they fail something or they get a bad grade or they're not, they have a bad day in a class, right? They still have that experience to say, you know what, I am going to be a good engineer, right? Because I built this with my hands, or I did this, and I know I can do this, right? And so that's kind of the goal of build nights and Fudge Up Fridays. Very similarly, it's also a part of my work in the Learning Factory. So we've just got a ton of good stuff happening in the Learning Factory. But Fudge Up Fridays similarly is about, again, just kind of bringing a bunch of students together. So we call it Fudge Up Friday because we give them hot fudge sundaes. You'll notice that food is a common theme in the events I run. um, but we give them basically, every Friday or maybe 2 Fridays a month. We have as many students as we can cram into Kunkel Lounge, which is one of the buildings on campus. So sometimes we have 100 to 180 students show up. We give them free ice cream from the creamery, which is always, good stuff. And we have a panel of engineering faculty, of industry alumni, of current, some more senior engineering students that just talk about times that they fudged up and how did they push through it and what did they learn. And they've been really raw, honest conversations, and I think a lot of our students have really appreciated that.
Yeah, that's great. It's funny, we do the food thing with students. You do sort of lose touch about how important that is, just having having access to free food when you're a student.
Yeah,
Is such a draw, but it's smart because it's just, then you get there and you actually have this major learning experience that you might not otherwise go to. And so it's just smart on your part. I wanted to ask just one thing, if you could talk about, so there's those things. And there's also, I know there's always a stream of, senior capstone projects and research projects. I wanted to make sure I gave you the chance to describe how, a lot of the people that listen to this podcast are senior people like engineers, leaders in industry, and, potentially could have the interest in engaging in these projects and in engaging in, sponsoring things. Can you give an idea of like, what are the things that are most valuable or that you would highlight?
Yeah, absolutely. So we have so many opportunities for engagement, just across the college, for industry collaborators. And I think, a few key things that I'll discuss, but again, there are so many more. But the Learning Factory itself has just a strong ties to industry. And so, as you said, Jeremy, we have something called Capstone, which is just a great opportunity for industry to come in and kind of sponsor a team of our senior engineering students to work on, a real problem that they're having at their company. And it gets the students to meet real world engineers, in quotes, and work on an actual industry project that really matters to a company. But also it allows this company to kind of get a really intimate understanding of, 4 of our top engineers in the college. So that's a really traditional way that we have for industry to kind of collaborate. Some new ways that I'm brainstorming and kind of leading are different ways to engage with build nights, with maker ambassadors, with some of these larger Learning Factory events. So, as I said, I run these build nights, which we have kind of pilot tested with a few of our industry collaborators where, these industry folks come and they kind of say, okay, we'd like to run a build night where we show engineering students what a day in our life looks like, what, some of our engineering work might be. So we had some folks come in and kind of teach, just a whole bunch of engineering students how they conduct vibration analysis, right, on some aerospace parts. And so similarly, we had their industry panelists come in and talk about their journeys. And it, I think a lot of recruiting events can feel very stale at times, right? Like very, transactional. Here's my resume. Here's who I am, and on to the next person. And, doing this recruiting event through a build night really allowed the recruiters to see students working on a real engineering problem and work side by side with those students. And it gave the students the opportunity to really understand what their job might look like and to understand all of the cool problems that they might get to work on. And I think, it was just so much more of an organic networking event. It was really just really a lot of fun. And so, we have opportunities to sponsor a single build night in similar ways where industry partners can kind of sign up and sponsor a build night and come in and get to work with anywhere from 20 to 50 engineers that sign up and are interested in kind of coming to that build night. And then we've also got different kinds of sponsorship through research, right? So I do a lot of research in product design and engineering design, and increasing the efficiency of the engineering design process. And so there's always opportunities to work on more targeted, higher level research projects with the faculty here at Penn State.
Yeah, that's great. I appreciate that, and I'm sure the industrial listeners will appreciate that too, especially the access to the students. I mean,
Sure.
it's both it's access to the expertise, but one of the big dynamics in the industry right now that everyone's conspicuously aware of, or at least most people that are paying attention are, but nobody has a good solution for, is just there's real workforce challenges. There's just so many experts that are getting ready to retire out of the workforce. And because, partly because of just the baby boom, population swell, but more, it's just because, young people aren't drawn, or at least don't think that they should be drawn to these roles. There's a pending shortage. I mean, it's actually not pending anymore. It's current. There's a current shortage of people that know how to make things work, solve problems, roll up their sleeves and design something, whether it's circuitry or sensors or IoT or whatever. There's something I wanted to ask you about, because it came up when I talked to Justin Schwartz, Dean of the College of Engineering, a couple weeks ago. He said something that really surprised me. He just knows the numbers, like the big picture numbers. And he said two things that are interrelated. One is that at Penn State, which is, quite a prestigious engineering school, half of the students are either newly graduating in the United States because they came from, elsewhere in the world, or they're the first generation in their family to go to college. More than half of Penn State graduates in engineering. And that's the first thing. And then the second thing is basically that we talk a lot about inspiring young people. And what he said, just I think very practically, is just that the real motivation that a lot of young people have is they just want to be able to get a job. They want a job that's going to pay them well for the education that they have. And it was just so simple. And I think that, for what you're doing, I think what you're doing is connecting these dots that helps to show that path, to these people, that if you have these skills, you are in such high demand, and the world urgently needs people who are doing these things. I'm just curious if, what you see when you interact with the student population and you see them going through that process from a freshman who is very uncertain or doesn't know what they really want to do, to a senior who then has an internship under their belt and they get a job offer. What are your observations on what the students really think and what pushes their buttons and what we could do better?
Yeah, I think one thing, and I completely agree, right? I think this is a comment. I think all humans need this, but, students need a light at the end of the tunnel. They need to be able to see themselves, with a successful career and in a successful workplace where they enjoy what they're doing. And I think that, a lot of times, and the way a lot of engineering systems are set up, right? You take your core courses early on. You take them your freshman, your senior, or your freshman and sophomore year, so you're just kind of overloaded with math and physics, and you a little bit lose this connection to that light at the end of the tunnel, right? That application, the practical application of the knowledge that you're learning, sometimes gets lost. And I think that is something that these extracurricular activities that I run at the Learning Factory, that my colleagues run, right? The Learning Factory is just so awesome at running these. That's our goal, right? Is to kind of show them that the light at the end of the tunnel is there, and to exactly what you said, Jeremy, to connect the dots that yes, you're learning, all of these fundamentals, but that there is this really cool practical application for them. And that there's this whole industry and this whole field that desperately needs them to be creative problem solvers, and needs them to, think creatively and try and solve these really wicked problems in ways that have never been solved before, right? I mean, that's really what we're looking at now, is that we need wildly different ideas to solve these problems. And so I think from the student perspective, right, it's all about making sure that they still see that light, that they still can envision themselves as an engineer, that they can, adopt an engineering identity, right? That that they can understand that engineering is more of a mindset and less of, a prescribed field, but that you can just do so much with an engineering degree, right? That you can, again, really, it's just all about creative problem solving. And so I think that that's, at least from what I hear with students, that's when I hear them the most tired, the most exhausted, kind of the closest to burnout or to kind of switching gears or switching careers is when they lose sight of that light. They lose sight of this is where I'm going to be. I'm going to have this successful career at the end. And so I think, any chance to reconnect them to that, to show them how fun engineering is necessary.
Yeah, I agree. I mean, I think it's really important work. I think it's challenging. You're finding a lot of success at something that most people really struggle with, and it's most people in terms of the traditional engineering education. I mean, specifically, I think it's really really important. I have a couple questions. To start, the clock always goes so quickly, but to start wrapping it up, I want to ask you the same question I ask everyone on these interviews, which is like, so you're working on that, and you're early into your career as a professor of mechanical engineering. I'm curious to know what is it that you find most motivating as a problem for you to solve? Something that you really you're really focused on and you want to improve over the course of your career.
Yeah, I'm happy to talk about that. There's of course lots of research problems that keep me up at night that I'm super motivated to solve. But I think that what we've been talking a lot about today is about education, and so I'll kind of stick with that vein. Something that really keeps me up at night is that even though, right, it's obviously very nice to hear that you believe I'm being successful in these things, but I still lose students, right? I still have taught students that come to me, a year later and say, I'm switching. I don't want to be in engineering anymore. And that is something that really, really does keep me up at night, because so often they're phenomenal students, right? They were some of the best students in my design class or engineering class, and to see that there is still this attrition rate is something that does keep me up at night, that I'm incredibly passionate about solving. I think that we need to widen the societal perception of what an engineer is, who an engineer looks like, right? Because I see so many students that kind of start to drop out because they say, well, I don't think like an engineer, or I don't really fit the engineering mold. And I think that that's one thing that keeps me up at night, is trying to figure out a way to help prospective students to see themselves as a creative problem solver, and understand that is the core of engineering, right? That is really the key ability that they need to be successful. And then figuring out, what kind of scaffolding do I need to provide as a professor to really get them to the finish line, right? What structures, what programs, what experiences do these students need to not only get them in the door, here at Penn State Engineering, but to retain them, to make sure that they're not surviving, but that they're thriving. That's something that keeps me up at night, that I'm like committed to figuring out and solving. And I think, at least right now, I really believe part of the answer to that is through design. It's through hands-on, fun challenges that um, really encourage this creativity and innovativeness in our students, and give them the opportunity to again roll up their sleeves, to just try something, to build something, with their own two hands, and see if it works pretty quickly, right? So that's kind of what I'm really passionate about.
Yeah, I appreciate that, Jess. That was actually one of the things on my list, and I'd like to spend just a minute on that before I move to the next question. Is just equity and inclusivity in engineering. Whether it's gender inclusivity or racial or ethnic inclusivity. I'm curious just to hear. I mean, I think that's part of what you're talking about is that that's where some of that people fall out of interest because they don't feel like it fits them. I'm curious, just like how things are right now. Or is it getting better, or is it getting worse? Or are we doing enough to encourage inclusivity in engineering at a place like Penn State for in those dimensions?
Yeah, so we again, you spoke with Dean Schwartz, and this is something that is really near and dear to his heart. It was one of the kind of his visions for the college was to get to gender equity, was to increase the number of minoritized students that we have in engineering, and I think that it really feels like there's a lot of momentum, Jeremy. There's just so much movement. I feel like we are actually starting to get somewhere, right? I think so long it's kind of been this like cycle of I don't know if we're making as much progress as we should be, but it does feel like there's a lot of momentum behind these initiatives, and I do think give us another few years, and there's going to be some real changes to kind of the landscape of engineering here at Penn State, because there are so many people who are committed to working towards this, myself included. And I think diversity and inclusion is something that is not a skill that you can just pick up, right? It's about education. It's about educating yourself about your own biases, and that is something that is lifelong. And I think that there are enough people, myself included, in the college that are committed to this lifelong learning, this lifelong kind of commitment to creating cultures that are inclusive. That yes, I think we're headed in the right direction, and I'm really excited to see where we go, and to see how all of these activities that we're spinning up now, that we're testing out, that we're trying to create the supportive, inclusive culture that we need to really create and retain a diverse workforce. I'm just really excited to see how these things pan out, and again, and to learn what we're doing wrong, and learn what we need to do right.
Yeah, it's just so important. Just again, it's a win-win because the workforce needs the best people, and people need the jobs, and the stability in the
Absolutely.
jobs, and it applies to everyone.
Absolutely.
And I mean, just personally, I have a son and three daughters, and I would be really interested. I work with them I've been very ineffective in encouraging them to become engineers so far. And I also know, our co-founder, Professor Gary Koopman, his wife Barbara Bogue was heavily involved in the Women in Engineering program at Penn State for years, and really worked at it just increasing the percentage of female engineers at Penn State. Which leads to my next question, because I just this is something we can measure. I think you when you look out a few years, or 5 years, or 10 years, what do you think it's going to be like when we get to 2030 in terms of that specific problem, just getting kind of like wide open appeal, so that the most talented people can understand how to find roles, if they're interested
Sure.
in these engineering roles.
Yeah. So, I mean, I always joke. I always say, I think we'll know that we've done great when it's 100% women in mechanical engineering or something, right? Like, nobody. And I think some of my male colleagues kind of balk at that sometimes, but I often point out that nobody seemed to raise any eyebrows when it was an all man or mostly men department. And so I think obviously I'm joking. But I do really think we'll hit gender parity, we'll hit gender equity, and I hope the same is true across for minoritized students as well, right? And that it's not just that that it's so much more than just men and women. It's this intersectionality that we need to focus on, right? The intersection of so many identities. And so I guess that's a long way of saying I think in 2030, I hope in 2030 or in 10 years that we have reached a place where the intersection of all of these identities of race, of gender, of sexuality, of every single thing is really celebrated. The diversity is really celebrated, and I think we're getting there, right? In industry, there's so many studies to point to the financial benefits of diversity, of having diverse, particularly engineering design teams, right, where you get more innovative solutions. But often it's a double-edged sword because having differences can lead to conflict. And so I think my hope is that we reach a place where this diversity is truly celebrated, not ignored. I don't think that makes sense, but again, really just celebrated for the strength that it is, right? For the strength of having so many different perspectives on a problem, which is always good, right? That's how you get creative solutions is through multiple different diverse perspectives. So that's, I hope that the landscape looks, shockingly different. Well, you know what? Here's what I hope. I hope that the landscape of engineering in 2030 looks incredibly different, but it's not shocking that it looks different. That we've put in the work and we know why it looks different.
I like that. Yeah, that's great. Yeah, I agree. I mean, it's a really nice picture to paint because that's where we really need to be.
Yeah, absolutely.
So the last question I have is one I think you'll really appreciate, and it's just a question of divergent creative thinking, which is so core to you, which is why I think you'll appreciate it. And the question is can you share with us something that you really believe, something you hold to be true, but that most people disagree with you about?
That's a tough one. Let me think about that. Something that I truly believe. Okay, so actually, it's not as tough as I thought. So something that I really firmly, truly believe that I find a lot of people disagree with me on. I really believe that creativity is a muscle, and that you've got to learn how to flex it, and you've got to go to the quotes gym, and you've got to work at it. And I think that most people, when I say that, really look at me, and I hear common things, right? Like, well, I'm just not creative. I'm just not artistic. I just don't have that. I don't have a left brain. I'm a right brain, kind of whatever it might be. I often find this pushback. Well, I'm just not creative. I just wasn't born with a creative bone in my body. I hear that a lot. And it's just not true. I think that everyone can be creative, but it's a muscle. And if you let it deteriorate, then yeah, it's going to be hard for you. And so I think you've got to work at it. And that's really something I try and hit home with my students, because I hear it most frequently with engineers, right? Well, I'm not creative, right? I'm an engineer. I'm logical. I do better with numbers. And all of that might be true. It's certainly true of me, but I'm absolutely still creative. And I think engineering is the field that demands the most creativity. And so I just really try and knock that point home.
Yeah, I think it's funny, Jess. I would tell you, I asked that question at the end of all these interviews, and you said that it would be difficult to answer, and then it took you about 0.1 seconds to come up with an answer. Because and it's interesting because you're fundamentally divergent in your thinking, but I think it's a great answer. I can personally relate to that. I think that a key takeaway I would add is just that you just anyone that does sports knows this, and most things are like that. You can become good at almost anything if you practice.
Exactly.
We just don't practice creativity. I think that's great.
Absolutely.
Hey, is there anything else you'd like to add, or just in closing, and then we need to wrap up?
No, I think I would just want to add that, if anybody's interested in kind of working or hearing more about any of these kind of initiatives we have at Penn State, feel free to contact me. But I just want to say I really appreciate the conversation, Jeremy. It's been great to kind of discuss these things with you. Definitely very, very insightful and been really nice to reflect on.
Absolutely. I've appreciated the conversation as well. And I really just congratulate you on the work you're doing. I think it's very important in addressing some of the very real workforce issues that are facing our country and the whole world. So yeah, thank you for doing what you're doing.
Thanks very much.
With that, we'll wrap up. And this has been Professor Jess Menold from Penn State and the Industrial Transformation Podcast.
Thanks for listening to the Industrial Transformation Podcast, a production of Business Builders Media. Learn more about how KCF can help you on your industrial transformation journey at kcftech.com and check out more shows on businessbuildersmedia.com.